Okay, so, label the fundamental triangle, which is all I ask you to do here, and people are at various stages of labeling this thing, okay? The idea of the fundamental triangle is all the information goes in that fundamental triangle, and you don't want too much other information there. So it can be spotted easily, so you can understand things, about the rates of change and the way rates of change and so forth. And you won't know what I'm talking about till we get there, but there's good reason for the labeling. So let's say that my points are 28, 6, and 14, 11. Okay. Then labeling is really pretty simple. Generally, we think left to right, and if we follow that convention, rise is negative 14, right? 28. I know you're looking at me like I'm crazy, and there's good reason for that. Okay. First thing I think of is what goes first. But of course, it's the Y coordinate that ought to go first, 6. The X coordinate that ought to go first, 6, 28, 11, 14. Okay, so now the rise 28 down to 14, right? Now, it actually is a good idea if you got room. It's a good idea to make room, to make your graph big enough to do it. Full calculation of the rise right there. Not off to the side, not someplace else where you're not going to spot it. Okay. Right there in the triangle. The triangle is big enough, and the one I gave you the homework filled most of the page. Okay. That's what you would want to put down if you have room. Okay. If not, you just put the minus 14 there. It's a small triangle. And then maybe off to the side someplace, not right on the triangle, do the calculation. Okay. And identify it. And do it in an organized fashion. And run. Which is the change in X is 11 minus 6 equals 5. Then up here, I'm not going to label this as a slope. We're going to do a calculation out here someplace. Nearby, because I really want you to write out all these words. It reinforces what you're doing, so you don't forget it as easily. I mean, given enough time, you can forget about anything. Okay, slope is rise over run, which is negative 14 over 5. And a decimal approximation is okay. It helps you see how big the slope is. So I could say, if I have room here, all right, negative 14 over 5 equals negative 2.8. Now, either negative 14 over 5 or negative 2.8 would be okay if you don't have room. The labeling includes minimal labeling, Include the coordinates of the point. The slope. A rise. And a run. But all the information is there. You can check yourself quickly and easily without having to look at a bunch of calculations scattered all over the page. Okay, it's organized, all the information is right there at your fingertips. Okay. So if something is wrong, you can quite easily spot it. So this is why we label the thing. In this class, not in other classes, it's not emphasized as much, but since that fundamental triangle could be argued to be most fundamental thing in calculus. This is a pre-calculus course. I think it's worth labeling. You have the misfortune to be in my class, so I want you to do this. Okay. And another thing is, since that's the way it's been defined, you're going to do the details. You want to be attentive to the details of the process. Here's what could be important. Okay, well. Okay, let me pause a second. Who gives squaring or reciprocal quadratic function? Is y equals f of x equals x squared. So we have x values, and we're going to have y values. Okay. I'm just going to give you a minute or so. Just copy this down. I'll have to copy every word that I did to get the table down and fill in the y values. Okay, now, one of the first assignments I'm going to give you is on exponents and stuff like that, calculating some numbers. So I'm skipping right to this. I wanted to see this to see how much you're going to need that one. And most of you pretty much need to be up on it. Okay, to square -2, take -2 and you square it, and that's -2 multiplied by -2, which gives us 4. You see a lot of -4s when we do this, and that's all good. But if you got +4, that's good. Got -4, fix it. Okay, you're multiplying a negative by a negative. That's what it means to square a negative number. Okay. Any number you square is going to end up positive. If the number is negative, we're doing a negative times a negative, it's going to be positive. If the number is positive, well, you're going to get a positive. You don't have any negatives to worry about. Okay, so same thing with -1. -1/2. Multiply fractions, you multiply the numerators and you multiply the denominators. 1 times 1 is 1. 2 times 2 is 2, you get 1/4. And common sense, why is, well, we'll do it, we'll square the 1/2, okay. And of course, you got 2 negatives, it's gotta be positive. What's 0 squared? Well, 0 times 0, it's 0. 1/2 squared. Now, I wrote it kind of small, it should show up on the video, but I wrote 1 times 1 over 2 times 2, because that's how you multiply fractions, okay? So there are reasons for that, and we really should understand the reasons at the level of the arithmetic, but that's something we talked about in this class, okay? 1 squared is 1, 2 squared is 4. Okay? So this is one of your toolkit functions. Now, there are the numbers. Write it out without all the clutter. I'm going to ask you. Get your graph. Want to see how you do with it. Well, I want to see how much I need to explain so everybody is in good shape with sketching a graph. Now, look carefully. Our x values need to go from -2 to 2. We don't need any more than that. So there's 2. And over here at an equal distance from 0, we have -2. And then, as we've been doing, we've got our scale here. So we divide this interval in half and we get 1, which is convenient because we've got 1 here, right? And then we divide this interval in half and we got 1/2. So if you're not subdividing these carefully, and take a look at this video or some of the other videos. We've got 1 here. 1/2 separate but negative, of course. All right. And now 1/2 is half as big as 1. And 1's half as big as 2. They have to be. Otherwise, you have a distorted graph. It's going to be distorted. If you do a freehand graph, the minor is distorted. You look at the board at a weird angle. I'm not a great artist anyway. Okay. But I can do a fairly good job. Okay, so I'll put 4 up here. Because of course, 4 is the biggest number we need. 0 is the smallest number we need. So I didn't put a big space for a y-axis down below. I knew everything's going to be above the x-axis. So I subdivide that, then about halfway point. That's 2, that's enough. And it's not too bad. Looks like it's going to be too big. Probably is a little bit. And then here's 1. Now, what are we going to need? We're going to need 4. We don't even need 2, but we need to subdivide this interval. We might as well label it. And we subdivide this interval, we get 1. Then we need 1/4. How are we going to get 1/4? Well, we divide the interval from 0 to 1 in half. That gives us half. Then we got to divide it in half again to get us a 4. So there's a 4. Now, without going into detail, I'm just kind of slopping this. Everybody knows how to locate points. I don't have to explain this. So there we've got points on the graph. Make them more visible. not perfect. This line has gone down a little bit, so this is a little lower than this, and should be at the same level. So the graph is completely symmetric. Because everything you've got to the left is zero, is just a reflection of everything you got to the right. Okay. Now, let's sketch a curve. And if you did it a little more carefully than I did, you're gonna have a really good graph. Mine's kind of okay. But it's not totally symmetric, it's a little lopsided. This line is a little too far to the left, and maybe even a vertical line. Kind of squash it a little bit. But there we have at least a reasonable graph of the x squared function. So whereas up to this point, I said just slap down a parabola and make your estimates. We can now construct a really good parabola in just a couple of minutes. Now, open math doesn't ask you to construct much of anything. It does ask you to plot some points on a graph. And when it does, it grades it wrong, so I've got to go back and fix the grading. Okay, no matter what you do, it tells you it's wrong. And 99% of the time it's right. Okay. So if it asks you to plot down points and tells you, says put down 5 points. You put down 5 points and says, hey, you need to put down 5 points. That's ridiculous. Okay. You put down 5 points. 2 of them are to the left of the y-axis, 2 of them are to the right, because that's what the instruction says. It says, hey, you got to put 2 to the left and 2 to the right. It's wrong. Okay. I go through and regrade that. I don't know what's the matter with it. It's a good exercise, but it kind of throws people, so be aware of that. Don't let that freak you out. Do try to get them right though. Okay, so there's your graph. What can we do with that graph? Well, I want to figure out what 1.6 negative 1.6 squared. Okay, I happen to know what that is. Square 16 with the decimals in. Okay, but let's see. Here's negative 1.5. Here's negative 1.6. Which x equals negative 1.6. I'll draw a vertical line. For x equals negative 1.6. Then if I come up here, draw a horizontal line. That tells me, according to this graph, what the square of negative 1.6 would be. So let's see how we did. That one actually looks like it's going to come out fairly close. Okay, so I subdivide this interval in half. And there's 3. So according to my graph, what do you think y is here? Okay, I forgot to record, but we're trying to estimate the y coordinate here that corresponds to x equals negative 1.6. I'm saying most people said 2.5. From where you're sitting, that's probably good. From where I'm standing, it looks a little lower than 2.5. So I'm estimating 2.45. Okay. So our estimate is negative 1.6 squared equals 2.45 because y equals x squared. At every point on this graph, if the graph, to the extent that the graph is done accurately, every point of this graph tells you the square of some number. So we have an estimate from our graph. It's actually 2.56. We're off by about a tenth. I was off by about a tenth. And I commented in the last class, I did one of these and I came out with really not a very good estimate. It was really about 3/10 off instead of a tenth. If the graph is completely accurate and the projection lines are all completely accurate, you are going to get the square. Okay. But you're not going to be able to draw a completely accurate graph and completely accurate projection lines. You get really accurate if you have drafting tools and stuff like that. But that's not the whole thing. The reason we're doing this is to understand where these numbers come from, where the shape of this curve comes from, and what everything means. Okay? Okay. So that's one of our toolkit functions. Now, so far, there are three of them that we've talked about. Got the toolkit exponential function. I was gonna do y equals 1 over x reciprocal function here, decided to do it over there for good reason, but apparently the brain couldn't hold that back long enough for me to write the right function. Okay, so y equals 2 to the x. So I want you to calculate these. No calculators. And since there are no calculators, there are a couple of values there you're not going to be able to calculate because you don't know. Neither do I. Nobody does. Okay. You don't know the accurate value of one of those, and you can't calculate it by hand. Now, I know how to approximate it to any number of decimal places. Takes a while to do it by hand. We'll do 10 decimal places, you might be at it all afternoon. Okay. But that's second semester calculus. And we're not going to do second semester calculus unless everybody tells me that you really want to do that now. Okay, anybody really want to do second semester calculus now? No, you got to learn pre-calculus before you learn first semester and then second semester, okay? And many of you won't even need a second semester calculus. Okay. So the point is, there are a couple of numbers here you can't evaluate. But you should be able to evaluate it for the rest of it. In the toolkit, reciprocal function. Is y equals 1 over x. So we make a table. We always use the same numbers. The open math is going to use other numbers. The open math is going to use a calculator. Because open math, the way, with the material I can find on open math, doesn't seem to think it's important to understand the arithmetic. Just do it in a calculator. I think that's a recipe for disaster. Open math is great. On this, I disagree with them. Or at least I think there ought to be something besides decimal approximations on a calculator. Okay. And what I just said, you got these calculations. There's a pattern. You should be able to get the pattern by going from here to here to here, and then continue the pattern. If you recognize the pattern, and if you don't, you will once it's really over there. Once we see it, let's get the camera over a little further. Okay. So start at the top, work down as far as you can. See if you can recognize the pattern. Okay, so what's the pattern here? First of all, we want to think about what things mean. Okay, they just punch 2 to the third into the calculator and get 8. Okay. But we want to see the pattern as best we can. Let's write out what 2 to the third means. 2 times 2 times 2. The answer is important, but not as important as how we get it. Okay. 2 to the second. That's 2 times 2, that's 4. 2 to the first, what's that? That's just plain old 2. The exponent tells you how many 2's you got to multiply. Okay. Okay, so there's a pattern there. Now, 2 to the 0. More often than not, even people come into pre-calculus want to write 0. They'll say 2 to the 0 is 0. Well, that breaks a pattern. What's the pattern of the numbers 8, 4, 2? Well, how do you get 4 from 8? You divide 8 by 2, you get 4, right? And if you divide 4 by 2, you get 2. So each of these numbers is half the one before it, isn't it? Okay. So if each number is half the one before it, this ain't 0 because half of 2 isn't 0. This has got to be 1. Okay. And that's true for any number. Any number to the 0 power has to be 1, except 0. 0 to the 0 power, we leave undefined. And there's a good reason for that. Okay, now 2 to the negative 1. Well, the pattern is each of these is half of the one before it. Okay, so 2 to the negative 1, it better be 1/2, right? And 2 to the negative 2 should be 1/4. 2 to the negative 3 should be 1/8. Okay. Now we go a little further. 1/4 is 1/2 squared. Here's 2 squared. It's 4. Here's 2 to the negative 2. It's 1/4, which is 1/2 squared, right? And 2 to the negative third is 1/8. Or 1/2 cubed. So what would 2 to the negative 10th be? Don't try to write out the number here. It's 1024, but yeah, how would you write 2 to the negative 10th this way? Well, write it out. What would 2 to the negative 10th equal? What power of 2 would that be? I'm on that. Pattern here is 2 to the negative 10. It better be 1/2 to the 10. Again, the pattern should be clear. If it isn't, if it's not totally clear to you why this should be, first of all, accept it as true. Second, come back to the video and look at what we said again. Okay. Every number here, every power is 1/2 of the one before it. Okay. So if you get down to 2 to the 1, half of that's 1. That's 2 to the 0. Half of that's 1/2. That's 2 to the negative 1. Half of that's 1/4. That's 2 to the negative 2. And of course, 1/4 is 1/2 squared. This number is the reciprocal of this number. Okay. This number is the reciprocal of this number. If you went up to 2 to the 10th there, then this number would be the reciprocal of that 1/2 to the 10th. Okay, so the rule is, I say obvious, it's not all that obvious, but the obvious rule . 2 to the negative n equals 1/2 to the n. Now, if you don't know that, You don't know that that's the rule, they're not able to evaluate these negative exponents. So now you see that two to the negative 2 has to be 1 over 2 squared, which is 1/4. Two to the negative 1, 1 over 2 to the 1, which is 1/2. 2 to the negative 1/2 is 1 over 2 to the 1/2. But you have no clue how to calculate that. Because of calculation, you can't write it out exactly anyhow. So we don't use numbers that we don't totally understand. We should totally understand these numbers, so we totally understand the construction of this graph. That's why we want to understand these rules. Okay, 2 to the 0 is 1, not 0. You put 0 in there, you're going to distort your graph. It's going to be really ugly instead of really pretty. Okay, we want a really pretty graph. Okay, and 2 to the okay. 1 over 2 to the 1/2, we don't know how. 2 to the 1/2, we don't know how. So we cross this off of our graph or table. We cross this off of our table. And we're just using -2, -1, 0, 1, and 2. Then we get 2 here and 4 here. And everybody pretty much calculates. Okay. This gives us a graph. I'm going to draw quickly. Using the same principle that we've used. So we have -2, 1/4. Well, here's 1/4. Now they're pretty close to the x-axis. Okay. And then -1. We get 1/2, so we get a point here. 1, we get, or x equals 0, we get 1. At x equals 1, we get 2. At x equals 2, we get 4. Then we have a nice smooth curve like this, and we've already seen early in the course. This is the curve that gives you the value of an investment of a certain amount of money at a certain interest rate after the years. It shows you how money grows. Also shows you how inflation grows. You've got to balance that. Okay. Also shows you how bacteria grows in your food. It grows very slowly, but the more bacteria there are, the more bacteria they make. And pretty soon, you hit the level of food poisoning. Okay, it doesn't take too long. So we want to follow guidelines. Okay. Okay. Now, what about the reciprocal function? As usual, fractions are an issue. Okay, so 1 over x, y equals 1 over x, okay? So y is going to be 1 over -2. That's negative 1/2. That's not a problem, right? X equals -1, y equals 1 over -1. Well, that's -1. 1 divided by 1 is 1. You got a negative, positive divided by negative, it's going to be negative. Then 1 divided by -1/2. Let's leave that off for a minute. One divided by 0 is undefined. We've talked about why. You can't divide by 0 because you can't count the 1 by zeros. Okay. Now what's 1 divided by 1/2? Can you count to 1 by 1/2? Well, they'll give you $50. How many more $50 do you need to make 1? You need 2 $50 to make 1, right? 2 halves make 1. To cut something in half takes 2 of those halves to make the whole thing, right? That's what it means. 1 divided by 1/2. How many 1/2 are there in 1? There are 2. Well, turns out that the rule for calculating is 1 times 2 over 1, because it makes that work. Makes the common sense of what it means to divide by 1/2. They do a rule and it works. So if you want to divide by 1/10, you get 10. If you want to divide by 1/100, you get 100. Okay, that's a rule for fractions. I've got to assume you know that. That's 5th grade math. Okay, doesn't mean that people come out of K through 12 knowing 5th grade math, because everybody forgets 5th grade math when they put the calculator in their hands. Okay, but you learned it in 5th grade, so it's going to be really easy to get it straight. Now, there you have the rules. You need to focus on the rules for fractions. Okay, kind of emphasize that already. So 1 over 1 is 1. 1 over 2 is just 1 over 2. Okay, and then 1 over -1/2. Well, it's just 1 over 1/2, but with a negative. That's -2. Okay. Now, normally I would have you plot these, but we'll take it a little time. Just some of the detail. I'm going to go ahead and plot the reciprocal function. I want to do something with it. Not labeling all these points. But obviously they're these points, okay? Except for 0, we don't do 0. So we plot this, and plot. We have -2, -1/2. I better put my -2 label up here, because my -2, -1/2 is going to be here. -1, -1 is here. -1/2, -2 is here. That's starting to look familiar. It should, because we've been talking about the shape of that graph since our first class, since our 4th class. Okay, so we're going to have a point here, a point here, and a point here. And now we have a pretty accurate graph of a reciprocal function. And that graph is constructed with numbers that we deeply understand how to calculate. So what I want you to do is sketch me a fundamental triangle and label it. These 2 points. And then sketch one and label it the point that's about here. And a point that's about here. And these two are graph points, so you know what the coordinates are. You don't know what the coordinates of these are, so you're going to have to estimate them. And don't take too long to do this. And if your estimates aren't great, that's fine. Just want to get the idea. Okay, we want to be able to do this pretty quickly. Your fundamental triangle here, you sketch vertical line, horizontal line, and hypotenuse. Okay, vertical line below this point, horizontal line, this point to this, right through this point. Here's your fundamental triangle. The rise is -1. You're going from 2 down to 1 because, of course, this point is 1/2 2, and this point is 1/1. Okay, then your run is one minus 1/2, which is 1/2. So your slope, which they can write the calculation out there. Slope is rise divided by run, which is 1 divided by 1/2, which is 2. And we put a little circle around that, but then -2, so -1 divided by 1/2, -2. And then you put your -2 in a box right here. Okay, and then the thing is, the interval where x goes from 1/2 to 1, there's your interval, 1/2 1 corresponds to that run. Average rate of change is -2. Now, we'll have time. But quickly for homework, we need to do the rest of this second packet I gave you. And it includes a lot of problems, probably 50 or more calculations with just plain numbers. What I need to see on this is I need to see your work. So you've got a column of calculations here, okay? I don't want to see just answers over here. Those answers can come off the calculator. And some people might be tempted to do that. You're not going to understand the graphs. You're not going to understand the functions. If you don't know where the calculations come from. You might understand some things about the functions. Might even understand enough to squeak by. But you're not going to understand them as well. You really have to understand the 5th grade arithmetic that's involved here. Actually goes a little beyond 5th grade negative exponents, you don't get. Okay, but middle school or pre-algebra. Okay. But again, people are in the habit of using calculators without understanding the numbers. So what I want to see is the details of the calculation. Just like I've got the details here. Okay, I want to see the details of each calculation showing how you use the rules. I've got the assignment on exponents that you can do today. I'm not sure that one got into the negative exponents, so it kind of expanded it. But with all that, you should be in pretty good shape here. There's some tricky ones, If you miss a few tricky ones, well, I'll notice. And we'll, one way or another, address it. But then you get to the last three problems, which just asks you to make tables for these functions and graph them. Make sure you do that. Don't copy it down from your notes. Don't copy it down from what you did in class. Do it with a blank sheet of paper in front of you. Do it. If you get confused on it, well, that's understandable. Go back and review and take another blank sheet of paper, put everything else away and do it. Make sense? That's how you learn it. You don't learn it by copying it down and thinking you understand it. Okay? It's not difficult. But take a little practice. Okay? And then ask you to do some estimates, things as fundamental variables, rates of change. Okay? So should be able to do that. If you got questions, email me. Or come by, very outside. And we'll go to the mark. Okay, all kinds of options. And do the best you can. I'm also assigning the section in open math on functions. Okay. And there might be some things I didn't explain to you, but the open math should explain it, the text should explain it. And of course, I expect that we'll probably see some issues with that and we'll address them. I know whatever. Okay, makes sense? And so do your best on this. It really nail these. They're the foundation of the course. And the work we've been doing with graphs. Okay. Very good. Got a question? Stick around for a couple minutes, but